G'day team, welcome back to another video, and today we are starting a brand new playlist and we're going to be starting to look at discrete random variables. So a random variable uses numbers to describe possible outcomes of a random experiment, so it is all to do with probabilities. Now we need to be really careful about the difference between discrete random variables and continuous random variables. Now we will look at these later in the year, but for now we're going to focus on discrete. So discrete random variables are counted and has distinct possible values. So you've got to be really careful that it has to be a whole number and has to be counted. Now, continuous random variables are measured, so often like your weight or your height, and take any value within an interval on a number line. So you've got to be really careful about the difference there. So we're going to be focusing on discrete random variables for the next few videos. So suppose I have two four-sided dice, and they're rolled, and my random variable x is the sum of the two dice results. We're going to state the possible values x can take. We're going to list the outcomes and the corresponding values of the outcome. And then we're going to sort of talk about the possible values of x being equally likely to occur. So what I want to do is work out what my possible values can be. Now, the two smallest values on my two dice are 1. So that means the lowest sum that I can get is 2. Now, the two highest values I can get are 4 and 4. So the highest sum is going to be 8. So that means my random variable x can take the possible values from 2 through to 8. So if I ever roll two four-sided dice, my sum will always equal one of these numbers here, okay? Now let's list the outcomes. So you've got to be very careful with outcomes because it's not about value, it's about what provides a value. Now, the way I've set this up is I've got dice 1 in the first column and dice 2 in the second column. So I've listed all the outcomes where die 1 ends up with a 1, and then die 2 changes, then die 1 has a 2, changes, 3, changes, 4, changes. So looking at the values that each outcome produces, I've got outcome of 2, outcome of 3, outcome of 4, outcome of 5, because I'm adding them together. 3, 4, 5, 6, 4, 5, 6, 7, and then 5, 6, 7, 8. So the probability that an outcome occurs is how many of the outcome or the value we see divided by how many outcomes there are possible. So we can see there's 16 outcomes possible here. So the probability of getting a value of 2 is 1 in 16 because there's only one outcome that produces a 2. But if I look at an outcome of 5, I've actually got 4 different ways I can get a 5. So that means the probability of rolling a 5 is higher than the probability of rolling a sum of 2. So that means the possible values of x are not equally likely to occur. So you've got to be really careful versus outcomes and values, okay? So values and then outcomes that cause the value. So you've got to keep that in mind. So what we want to look at is a discrete probability distribution, and that will show us how our event is going to be distributed. So we're going to say x is a random variable with possible values of x1, x2, x3, all the way up to xn, however many. And those events have a corresponding probability, or those values have a corresponding probability of p1, p2, p3, all the way up to pn. Now, our first little rule is all of these probabilities have to be between 0 and 1 inclusive. That makes sense because we're looking at sort of a percentage. We can't have a negative probability of something happening, and a probability of 1 means it's definitely going to happen. So we can't go outside of those limits. Now, the sum of all of the probabilities in the distribution must add up to 1. So that means if this value is taken, or any value is taken, if something's going to happen essentially. So we've got to make sure all our probabilities add up to 1. And then finally, the set of our probabilities for each value describe the probability distribution of my random variable x. So looking at this little example here, so we've got x is the value of a 6-sided die. The possible values for x are 1, 2, 3, 4, 5, and 6. And the corresponding probabilities of rolling those values are 1/6 for each of those values and outcomes. Now we can display this information in a table or a graph. So I've got x, which is my value, so 1, 2, 3, 4, 5, and 6. And then the probability that my random variable equals the value or outcome. So there's a 1/6 probability of getting a 1, 1/6 of getting a 2, etc. Same thing with a graph, except we've got our values along the x-axis and my probabilities along a typical y-axis there. Okay, so we can see that they're the same. Now, if we do have a probability distribution where all the probabilities are equal, then we say that's a uniform, discrete, random variable, and it's because all probabilities are the same. So you do need to be able to identify that as well. Now, two more things that we can look at. We can look at the mode and the median of our sort of random variable. So the mode will be the value of xi, so the value of whatever x or whatever value outcome we have with the highest probability pi. Okay, so we look across our distribution function and we find the value with the highest probability. Now the median, if the values of x are in ascending order, which typically they will be, we add up the probabilities until we reach 0.5 or more, and then the value that makes it reach 0.5 or goes over is the x value we take for the median, okay? So let's have a look at an example. Now Scroll Queen down here in Mount Gambier kept a record of scrolls, sold on Saturday. 22% of them bought 1 scroll, 41% bought 2 scrolls, 19% bought 3 scrolls, and 12% bought 4, and 6% bought 5. Let X be the number of scrolls sold to a random customer. So let's state the possible values of X. So the number of scrolls is my random variable. So they can take the value 1, 2, 3, 4, or 5. So let's put that information here. 1, 2, 3, 4, 5. Now it says construct a table. So we put our values in the top of the table, 1, 2, 3, 4, and 5. And we write the probabilities. Now we can't write decimals. So 0.22. Now 2, there's a 0.41, 0.19, 0.12, and then finally 0.06. All right, so nice easy table to construct there. Part C, show X as a valid probability distribution function. Now the easiest way to show that a distribution function is valid is by showing that the probabilities add up to 1. So I've got 0.22 plus 0.41, which is 0.63, plus 0.19, which is 0.82, plus 0.12, which is 0.94, plus 0.06, which equals 1. So we can say that this is a valid probability distribution function. Now we want to find the mode and the median. Now the mode is the one with the highest probability, which is 0.41. So 0.41 correlates to the value of 2. So we do that over here. Now the median, we add up the probabilities until we go 0.5 or more. So we start with 0.22. That's not 0.5 or more, so we add the next one, which is going to give me 0.63, which is over the limit. So we take 2 as our median as well. Nice and simple. Now, one thing you'll also be asked is to find the probability of exact things happening and events occurring. So find the probability that my random variable is equal to 2. Well, that's just the probability that we get 2, which is 0.41. Now, F, probability that X is less than or equal to 3 is the probability I get 1 or 2 or 3. Now, when I use that word or, I have to add the probabilities together. So I've got the probability of X equaling 1 plus the probability of X equaling 2 plus the probability of X equaling 3. So looking at that data there, we can say the probability of X being less than or equal to 3 is 0.22 plus 0.41 plus 0.19, which we said before was 0.83. So there's a 0.83 probability that someone will walk in and buy 3 or less scrolls. Okay. Oh, I accidentally put that. Should be there with part C. All right, so that's a really good example of showing a different range of questions, and hopefully that helps. Thank you for watching, and I'll catch you in the next video for some more discrete variable